Hello everyone, welcome back to Edumoon tutorials. In this particular lecture, we will be covering canonical and standard forms. Don't worry, the video might be a little longer, but by the end of the session, you will have a complete knowledge on how to solve problems given under this section. Myself Sohana of Andhra University, and let's get started. Now, Boolean function can be represented in two forms, which is SOP and POS. Now, what does SOP stands for? It means sum of products. And POS means product of sum. Now, let's get into a greater definitions for this one. Now, SOP is a group of product terms summed together. Like you can see the example here, AB plus AB bar C plus BCA. The product terms, these are the product terms. AB is a product one and AB bar C is a product and BCA is also a product. Now all of these are summed up. Now see, there's a plus symbol. So this is an example of SOP. Now SOP can also be called as disjunctive normal form. Now it can be represented as sigma. The usage of sigma will be taught clearly in the coming part. So don't worry about that one. Now coming to POS. It's a group of sum terms. I forgot to give here an example. So you can just consider an example to be A plus B dot B plus C. Something like this. Now, what does the definition say? It's a group of sum terms multiplied together. So this is a sum term A plus B. There's a sum here. So this is a sum term. And B plus C. So this is also a sum term. Now these two are multiplied together. So this can be an example of POS. Now let's see canonical forms. Now canonical forms are of two types, which is a standard SOP and standard POS. Previously we have mentioned only SOP and POS. Now what are the standard SOP and standard POS and why do we need them? Now for example, there is a question in your exam which says for a given Boolean function, the Boolean function can be anything in terms of A, B, C or something and etc. Now that one should be converted into an SOP form or into a POS form. You can't directly convert the given Boolean expression into either of those forms without the help of standard SOP. So at first let's look on to what standard SOP is and then let's look on to a few examples. So as the definition says, each product term contains all the variables of the function. Now see, for example, f of A, B, C equals to A bar, B, C bar plus A, B, C bar. Now in this each and every term, we have all the variables. This term has ABC variables and this term also has ABC variables. But this is not a standard SOP because for a given function, in this term, C is missing, right? So this cannot be a standard SOP form. This can be an SOP form, just a sum of product forms, but not standard SOP form. Just know the difference between both of them clearly. Now, standard POS. The definition says each sum term contains all the variables of the function. Now for this given function like f a b c d, we have a plus b plus c plus d and a plus b bar plus c bar plus d bar. So as this term is having all the variables, as mentioned, all the variables of a b c d, here it's present in some of the other form. It can be b bar c bar in anything, but this term has all the variables. Even this term also has all the variables. So this is a standard POS. Now for a given SSOP, it's SPOS. I hope you guys are clear with these two conventions. So for a given SOP, its SPOS can be obtained by taking its dual. I hope you're clear with the concept of dual. Dual is nothing but converting the AND gate into OR gate into AND gate, 1 with 0 and 0 with 1. But we are not dealing with their complements. Like the complement cannot be converted to its normal form. So if a function is given like f of a, b, c, d equals to a, b, c bar, d bar plus a bar, b bar, c and d, how can we write its dual form? Its dual form can be written as a plus b plus c bar plus d bar dot a bar plus b bar plus c plus d, because the dot in between them is converted to a plus. Dot in between them is converted to a plus, but the c bar remains as a c bar and d bar as the d bar, same. We are not dealing with their complements. Now here plus is converted to its dot. I hope you are clear with this convention. So for any given SSOP, its SPOS can be done by taking its dual. Now let's see other kind of definitions like min terms and max terms. So min term is an individual term in SSOP and max term is an individual term in SPOS. So for example, for a two variable function, you have variables like a and b, which is 0, 0, 0, 1, 1, 0 and 1, 1. Now min term is represented using these and max term is represented using all these. Now it's a 0 and 0, say a bar and b bar. But in case of max term, 0 and 0 is taken as like a positive one, like a plus b. Here it's an a bar and b bar, but here it is just a and b. Similarly, it's a 0 and a 1. So generally we put a complement for 0, like a bar for 0. So a bar b, but in the case of max terms, these are reversed. For 1, it is given the priority, like 1 is taken as b bar. Don't confuse with these notations. Now, all of these individual terms are represented using small m0, small m1, small m2 and small m3, and this one are written as capital M1, capital M0, capital M1, capital M2 and cap M3. Now, so for a given function of f a comma b equals to ab plus a bar b. Now, how are we representing these? Using minimum terms and maximum terms. So ab, here ab stands for m3, which is a 3. So it is written as sigma because we already mentioned in the previous one, SOP is denoted using a sigma and POS is denoted using a pi symbol. So it is a sigma of AB means a 3 comma, and A bar B is a 1. So this is a 1. So this is a representation for the given Boolean function. Now let's look on to few conversions, like conversion from SOP to SSOP. Now what are the steps that we need here? Identify the missing variable in product terms, multiply variable plus its complement in essence complement, and neglect the repeated terms. Let's look onto the example for clear understanding. Now consider the Boolean function f of a, b, c equals to this one. Now see, this is an SOP form because each term are in the product form and all of them are summed up. So it is an SOP form. Now we need to convert this SOP into standard SOP. What is a standard SOP? It should have all the values a, b, c in this term, and also should have a term in this one because a term is missing in this one. But in this term it has all the ABCs, so we are not changing anything regarding this one. So AB, how do we convert this AB? So AB into C plus C bar. We are multiplying variable plus its complement. So C plus C bar plus A, B, C bar, just dropping down, and BC is there. So again A is missing, so A plus A bar. Now expand all of these. A, B, C plus A, B, C bar plus A, B, C bar plus A, B, C plus A bar, B, C. Now, are there any repeated terms? Just check the entire statement. So, ABC is there, ABC is there. So, just write once, it's enough. Plus. So, this is done and this is done. And we have A, B, C bar, A, B, C bar. So, only once it is required, A, B, C bar plus A bar, B, C. Now, we obtained till here. Now, what should we do next? We need to find the values for this one. So, it is an A, B, C. So, it's a 1, 1 and a 1. A, B is a 1, 1. C bar means a 0. So, A bar is again a 0 and a 1, 1. Now, what is this 7, 1, 1 stands for? It stands for 7. And this one is equals to 6. And this one is equals to 3. So, finally, we represent this as sigma of 3, 6 and 7. So, your given function is a representation of sigma 3, 6, 7. I hope you are very clear till here. Now, let's look onto the other conversions. POS to SPOS. Now, first let's look onto the example like f of a comma b comma c equals to a dot a plus c. This is a term which is having a summed one, and this is also the other term. Now, these two are multiplied. So, this is a POS. Now, we need to convert into SPOS. How do we do that? Let's look onto the steps. Identify the missing variable. Add with that variable and its complement separately. Neglect the repeated terms. Now, let's look at the example. We have A into A plus C. In this one, we have B and C to be missing. And in this one, we have B to be missing. Okay. Now, how do we do that? A plus B plus C. I'll just write down and then I'll tell you later clearly. Bar plus C bar into A plus B bar plus C dot A plus B plus C bar into A plus B plus C into A plus B bar plus C. Now see, you might be wondering why I have written all these bigger terms. So in A, we are having B and C to be missing. So B and C, we have like two types, like two variables are there. So all the four possible conversions are BC, B bar C bar, B bar C and BC bar. I hope you are very clear. Like if it's only a single, like X, if it's a single X is missing, we can have X and X bar, right? But if there are two kinds, if X and Y both are missing, then we can have XY, X bar Y bar and XY bar and X bar Y. That's what I have written here. So instead of B and C, I have taken all the other possible terms also. Now in this one, we have B to be missing. So A plus B plus C and A plus B bar C. Now just remove the repeated terms. This and this are repeating, so we can write it only once. A plus B plus C dot. You need to carefully look on what all the terms which are repeated, and these two are also missing, right? So let's write it only once. A plus B bar plus C dot. So we are done with these two, and now this is a different one. A plus B bar plus C bar dot, and this is a different one. A plus B plus C bar. Now here comes the actual confusion. Now in the previous one, for all this ABC, generally we take it as 1, 1, 1, right? But in the case of POS, we need to take the normal terms to be 0. These are not ones, these are zeros. Don't at all confuse this point, because it will completely change your answer. So these all are 0, and for the B bars, like whatever it's complementing, that is taken as a 1. So this is 1 and these two are zeros. So this is, and this is a 1 and this is a 0, and this is also a 1 and these two are zeros. So finally what all we can have, like 0, 0, 0 stands for 0, and this stands for 2, this stands for 3, and this stands for 1. So finally we are representing it as 0, 1, 2 and 3. I have already told you the notation or description for POS is a pi. It's not a sigma, it's a pi. So till here we are done with this one. Now let's look on to few examples. Now here our first question is F equals to A plus B bar C as sum of minimum terms. At first, let's understand the question. Now given it is asked to find the sum of minimum terms. Now minimum terms means that we need it in the SOP form, right? Now this is also in the form of an SOP. At first, we need to convert this given SOP into standard SSOP. Like SOP must be converted to standard SOP. For that we have already seen the rules. So now the function here is A plus B bar C. So in this one we are missing B and C terms, and in this term we are missing A terms. So at first let's multiply the B terms for this one. So A into B plus B bar. This is because according to our rules for conversion of SOP into SSOP. So A, B plus AB bar. Now just in place of this one, just write everything. So AB plus AB bar plus B bar C. Okay, and now look onto the each and individual terms for this one. And the C is missing, and the C is missing, and this A is missing. So again, just AB into C plus C bar plus A B bar to C plus C bar plus B bar C into E plus A bar. Now it's an ABC plus AB C bar, just expanding all these terms. So A B bar C plus A B bar C bar plus A B bar C plus A bar B bar and C. Now let's look on to the common terms. If any common terms or like any repeated terms are there, just cancel them. ABC, just check the entire one. There's no ABC, so ABC is done. Plus ABC bar. Can you find ABC bar in the entire equation? No, right? So just drop down that one. Now a b bar c and a b bar c, so once is required, c plus a b bar c bar, there's no other term like that, plus a bar b bar c. Now okay, in case of SOP, we take all these terms to be 1. The complement are taken as 0. 0, 1, 0, 1, 1, 0, 0, 0, 0 and a 1. This is equals to 7, this is equals to 6, this is equals to 5, this is equals to 4 and this is equals to 1. So finally we can write the given function of ABC equals to sum of the terms like 1, 4, 5, 6 and 7. I'm just writing it in the ascending order so it will be easier for you to understand. So now we are done with this problem. Let's look at the other problem. Now, given question as f equals to xy plus x bar z as a product of max terms. Okay, this is a different question. This one is given in the form of SOP. Right? Now here they are asking it to convert into POS. Now, in order to solve problems like this, we have many methods. Like if you are very thorough with this complete concept, you can play with the numerals also. One of the techniques is that you need to find the SOP like the previous one, like SSOP, converting this into SSOP and then finding the sigma value of that. From sigma, you can get the pi of this one. But in order to avoid that step, like converting SOP into SSOP and then going on with the other one, we can easily do with this kind of property. First, we need to convert the function into OR terms by using the distributive law. Distributive law says that x plus yz can be written in the form of x plus y into x plus z. Now, okay, similarly, we are writing the question like f equals to xy plus x bar z. Now, how can this be written in the distributive law? Xy plus x bar into xy plus z. I hope you are clear till now. Now again, this one can also be written in the distributive law, like x bar plus x into x bar plus y and z plus x into z plus y. Carefully observe these terms. There is nothing to confuse in this one. Now x plus x bar equals to a 1. So just leave it like that and just write all this for x bar plus y into z plus x into z plus y. Now from these terms, like from this one, you can convert into standard. Now this is a POS. Now this can be converted into a standard POS. Right? I hope you guys are clear with this conversion steps because of the rules I have given in the previous one. Now start converting them. How do we do that? In this z is missing, in this y is missing, in this x is missing. So x bar plus y plus z into x bar plus y plus z bar. In place here, in order to add a z, we are just adding its complement for both of them, z and z bar. Now in this case y is missing, so it is x plus y plus z into x plus y bar plus z. Now z, in this one x is missing, so x plus y plus z into x bar plus y plus z. Now can you find any common terms in all this equation? Yes, we can find few terms. This one and this one is repeated, so just write only once. Y plus y plus z. Now I'm just cancelling these two, and in these two also it is repeated, so x plus y plus z. So I'll just cancel them. Now these two are unit terms, so just drop down them. X bar plus y plus z bar dot x plus y bar plus z. Now the main confusion comes here. For complemented ones, we are taking 1 because this is a POS. Okay. In case of an just make sure. For the bar ones, we take it as 0, but in this case, bar ones are taken as 1. Okay, so this is a 1, this is a 0 and a 0. So all these are zeros, and this is a 1, this is a 0, this is a 1, this is a 0, 1 and a 0. Now this value equals to 4, this is equals to 0, this equals to 5 and this equals to 2. So finally your answer can be like function of x comma y comma z equals to pi, because this is a POS problem. Pi of 0 comma 2 comma 4 comma 5. It's done. Now let's look onto the other problem. Our next question is find the sum of minimum terms expression. Here we need to find the expression now. So this is given in the form of a POS. Let's first understand the question. Okay, so this is a POS and the sum of minimum terms means an SOP. Right? Now there's a simple conversion between POS and SOP if these terms are given. Now for example, f equals to pi of 1346, then its sigma will be all the missing terms. Now the missing terms, like till where are the missing terms? It is only usually from 0 to 7. Okay, so 0 is a missing one in this one, so it's a 0. 1 is there. Okay, now 2 is a missing term, so 2. 3 is there. 4 is there. 5 is a missing term, so 5. And next 7 is a missing term. So this will be your sigma. So whenever pi is given, you can find the sigma, and whenever sigma is given, you can find your pi. Now how do we write the expression for this one? So 0 0 0, like for 0 it is 0 0 and 0. For 2 it is 0 1 0. For 5 it is 1 0 1. For 7 it is 1 1 and 1. Right? Now if we take this f function to be in the form of like x y z, like it can be anything, a b c or anything, you can just take 3 boolean variables, that's it. So if we take x y z, this one will be x bar y bar z bar plus because we are asked to find the sum of minimum terms, so we are taking in this case, so this is the product terms summed up. So 0 1 0 means x bar y z bar plus x y bar z plus x y z. I hope you are very clear till here. Now let's look on to the next question. You will be even asked a few questions in this format, like identify the minimum terms and maximum terms of the truth table for a given function of f. Now whenever you are given a truth table like this, there's simple notations for them, like f of x comma y comma z equals to, like you're supposed to find sigma and pi, right? Some sigma and some pi, something here. Now what these values generally stands for, this is a 1, sorry, this is 0 1 2 3 4 5 6 and 7. Always remember that for any values of 1, that one will be your sigma. Okay, so what are the values standing for 1? It is 1 3 4 and 6, right? Simple. 1 3 and 4 6. And what all the terms that are left apart from for sigma, those will be your pi terms, which is 0 and 2 and 5 and 7. That's it. I hope you're very clear with this one. Let's just see one more question. Like I want you guys to try solving this question, like express the following function as a sum of minimum terms and product of maximum terms. I'll just explain the question. Just try solving this one, so it will clear all your basics and all the concepts which I covered till now. So sum of minimum terms is SOP and the product of maximum terms is POS. So at first it will be easier if you convert the SOP, like this is an SOP terms, right? SOP into standard forms, SSOP. This is the syntax in which you need to do. So in this one C and D terms are missing, and this one A and D terms are missing, and this one B terms are missing. So you just multiply it with that variable and its complement, like A B bar into C plus C bar. First do that one, you will be getting a term, and then again those individual terms will be having a D value to be missing. So again do that, you will be having a bigger equation, like all the variables consisting of A, B, C and D, and from that one just rule out the repeated terms, and then finally you will be having a unique string of A, B, C, D. From that you can calculate your SOP terms, and whatever terms that are left behind SOP, those one will be your POS terms. I hope till here you guys enjoyed this class. In the next class we will be covering the other concepts. Till then, stay tuned to Edumoon. Thank you.